Okay. Today we are going to learn. This is the 12th week. So actually 13th week without the midterm. We are going to do Java unit testing. So now this is very important. If you want to become a QA people, like I want to become a QA engineer, quality assurance engineer, and you are going to work as an intern in the QA field. Business analysis also, this is a good trademark, and as software engineer also, unit testing is very important. Now they require unit testing skills. If you want to join as an intern in the second year, JUnit testing. So this is actually a framework available in Java so that you can test your product, whether it is working the expected result. You will be able to evaluate using this JUnit testing. So I recommend you to follow this compared to the other one because you don't need any loop or if condition knowledge or a method than the class knowledge here because it's a separate case, right? So Java unit testing framework. Now let's understand what is this unit test. Okay, now forget about the book definition here. Now let's open a calculator. Now this is created by someone from the Microsoft, some team. Okay, now I'm going to check whether this calculator is working correctly. So that is the logic, right? So your client has given you the application to develop. So this is the application, a calculator, simple calculator. Now, how do you know that this calculator works correctly? If I put 2 multiplied by 5, what should be the correct answer if the calculator is correctly developed? 2 multiplied by 5, what is the logic? If the calculator is correctly implemented, it should be 10, right? So, if you have done the coding correctly in the calculator, if I do this kind of a multiplication, what should I expect? 10. But if I get 15, that means what? The logic has a problem, right? There's a problem with the logic. So we want to check that. So if we get the correct marks, that is 10. If I press enter again, what will happen? Haven't used in the calculator. What should be getting? Enter press again. Multiplied by 5, right? Again multiplied by 5. That is how it's working. So if you don't get this kind of a behavior, so that means you haven't coded the calculator correctly. Now from your NetBeans ID, like from the knowledge that we have learned, you can code this kind of a calculator, right? Buttons, display, that can do that. So you can verify whether it is correct by pressing enter continuously. You should get multiplied by 5 continuously. If you don't do it, that is mean the logic is incorrect. So the software engineer, those who develop the software, have made an error. It's not a compiler error, it's a logical error. So how did we identify? By checking without. So we can't manually test it, right? Always each values. So that is why there's a way to automate this software. So if you search in the Google, there's a specific set of skill that required for become a QA engineer. One is automation skill. So you have to automate the skill. So one example is you can search Google Selenium WebDriver. So if you are going to test web application whether it is correctly working, for example, if you want to develop a shopping cart, and if you want to test whether the shopping cart is working correctly, you can use the driver called Selenium WebDriver. So one example is like that. So unit testing is another part of a tool where you can test individual component. So one example is this multiplication function. So this is a unit. This is a unit, right? So one single testable unit, whether you can multiply. This is another unit we can test. And this is another unit we can test. If I select CE, if the answer is like if the calculator is correctly implemented, then what should happen to the screen? It should blank, right? 0. So these are the individual units that we need to test using any kind of a tool. Now it doesn't have to be JUnit. So there are many tools like Selenium WebDriver, Apache JMeter. So there are automation tools that you can test it. But what we are going to learn today is a software called, it's not a software, it's actually a separate library that is called JUnit, Java unit testing. So we can ask in the exam, in your own words, what is a unit testing using examples. So you can take a calculator out and say that multiplication function is a unit that you want to test whether the function is correctly working. Now, if I go to the data.lk and click add to cart, what will happen to the cart? The cart should get incremented, right? 1, 2 items, 3 items. So that is one unit testing we can test. Like if you go to the Facebook and make a comment, if the comment is not posting, what will happen? That is a software bug, right? So that is a unit that we can test. So a unit is actually like that, the smallest unit that you can test. Now you can take your watch out and you can adjust the clock. If the second and the minute and the hour hand is moving, that means that is correctly working. So that is a unit that we can test. If I press this button, if this is coded correctly, like the circuit is correctly working, this projector should shut down. It should turn off. So those are the units that we can test. So we call it as smallable testable components in your program. Now let's learn about this JUnit, right? This is actually the advantage is this is an open source unit testing framework. So there are some tools that you have to work in the industry. Those are not free. But this one is free and open source for testing. But if you go to the industry, there are some paid products that you have to pay for testing that framework. But this one is a free and open source one. And this is a very good framework for Java because it has plugin for Eclipse, NetBeans, then we can say JetBrains. So Android Studio, there are many IDs available, but in JUnit there's a plugin for that. Okay, let me show the camera, right? If the camera is focusing. Okay. So yeah. So now what I was testing is like JUnit is an open source unit testing, right? So it's free. Now if you want to get it, you can just Google it. Go to the Google. Google. So here just say JUnit. Right? What is the latest edition? 5. Now this is the major version of programmer friendly testing for Java and the Java virtual machine. So I recommend you to learn this, right? There are some mini videos like how to test in a complex manner, but we just give you an introduction how to test small component. So this is, you can just download it and you can install it. So I'll teach you how to do that. So in the labs today we are going to do that. So this is actually have plugin for these kind of IDs, right? Micrometa, QCards, IntelliJ IDEA. So this is the JetBrains, right? This is one of the best tool that available for Java. But unfortunately, that Swing application, Java Swing, it's kind of complicated for the beginners. That is why I didn't do that. But NetBeans is actually what we can use it for our IDs. But these are available. These are gold sponsors, right? So that means if you install this IntelliJ IDEA software for your Java development, this has this JUnit plugin, right? So I recommend you to get that. But today let's see how to use it. Now there's another tool called NUnit. So this is for C#. The same purpose. So if you see some kind of a letter like J, N in front of it, now let me check that here. So you can see this is J and N. So this keyword is actually, we call it as XUnit family. Because it has a similar behavior. If you consider the NUnit, that is for C#. For PHP, there's something called PHP unit. For C++, there's something called C++ unit. You can download it and install. You can search on the Google. Each individual languages has different frameworks, like this unit testing. But all has a similar behavior. So that is why we call it as XUnit family, because the first keyword can be replaced with your language. Java, PHP, likewise. So this is what we call it as XUnit family. And this is actually that NUnit is for C# .NET frameworks, and you can use it for the C# application. Now let's see how to develop unit testing with Java. So what are the things that you need to have? So let's see what are the prerequirements. First of all, you need to have a source code to test. If you don't have source code, we don't have to test it, right? Then testing framework and testing methods. Let's write a source code. So you need to have a source code, testing frameworks, and the methods. So let me write a simple program. Let's open the NetBeans IDE. This one is actually an old one. Let's open the latest IDE. So you can like in the online students also, you can try to open the NetBeans in the meantime, so you can follow along with what we are doing it. We are saying no, yeah, we don't need the previous version. Yeah, this is the first time I'm opening this NetBeans IDE in this PC. And let's wait until the application works. Yeah. So once it is loaded, first of all, you need to activate these tools, and you need to go to the tools and plugin. So I need to activate the Java. Java SC standard edition. Activate it. So the plugin should be activated before you do any kind of JUnit testing. This PC is kind of slow, that's why it takes some time. Yeah, so after it's activated, we can finish it, close it. I'm going to create a new project. So Java with Maven, so Java application. So it's same, right? Doesn't have the steps are same. Okay, yeah, there's a problem. Some say that if you put optional, like if you don't give a package name in 13, you get some kind of error. But last week in the tutorial, I fixed that error. Like you need to add that only the group ID. If you don't give the group ID, that is the case. So group ID should be your company name. So you can say lk dot select, and I remove this package. And I can say version 1.0, and I'm going to say unit testing. I forget. It doesn't matter, right? You can delete the package. I forgot to remove this. That is why it's created. Because when you type your project name, it will automatically at this part. You can just remove it. But what is important is you need to add the group ID. So that is why it says unloaded. Some of you make sure this group ID is now. Here we have written a simple main method just for a demonstration, right? I'll delete it. We don't need this. Yeah, I just delete this first, the Java class and the package. So I want to start freshly, right? So refactor. So let's go refactor and delete, because otherwise not be deleted. Yeah, so then we can just delete it because we haven't used it in the project. We don't need this. Okay, now default package is there. So I'm going to create a new Java package. Let's say code. So these are where we have your code. I'm going to write a simple formula. Let's say Java class. Simple formula for a rectangle. Now, what are the information that rectangle has? Can you tell me? Width and height, right? So we can have a width, and we can have a height, right? So you can generate the constructor. So that's how you do it. So then I'm going to write a method that should be calculating the area of this rectangle. So what is the formula? Width into height, right? So let's say calculate. Yeah, so let's wait until the power. Okay, so the power was failed, that is why there's a pause. Let me turn on this projector so one can see it. We'll wait some time. Please. Yeah, you can see it now, right? Okay. So now the calculate in order to calculate the area, we can create an area function that will be width into WIDTH. But I put accident. Like let's say I made a mistake. So this is incorrect, right? I made a mistake. Imagine I made a mistake like this. I accidentally multiplied by 2, but I didn't know that. Because if you write a large formula, sometimes you miss the logic. So how do you identify it? Is you can test the function. But automate, right? Rather than manually run it, you can automate the software using this unit testing tool. So let's return it, the area. The software developer didn't know this. They gave it to the QA. Now the QA person, they have only the output and expected inputs. That is what we provide, right? Inputs and outputs. So in order to do that, now we have a source code to test. So let's see our logic. Now our pre-requirement, do we have the source code now? Yes. The source code is there. What is the source code we are going to test? That rectangle glass calculate area function. That is my source. Second one, what we need to have? Do I have the framework? No. Method? No. Let's try to install the framework. So in order to install the frameworks, you need to go to the Google and search Maven repo. And you can find the JUnit testing because that is one of the famous repo. You can Google it. And this is what we need to have. Like there are two JUnit. We can use whatever the version, but I will use the JUnit file. You can get the latest version, which has large usages. And you can copy this. Jupyter API is what we need to have for the framework. So we want to install it. So what I want to do is click on this Jupyter API. I'll copy this one. Dependency tag, I will copy that. Now there's a project object module file you can see, right? Open that. Now within this project, we want to have a dependency. Next week course we are going to use that when you do the connect into the database. So you need to have something called dependencies. So this tag we need to have dependencies between these two tags. We can paste our. Don't just directly paste it. You need to have what? Dependencies and paste the tag of the first dependency which we are going to add. Once you add this dependency, you have to wait some time until they download it. So currently, you can see a testing framework, Jupyter API 5.8.2 Java file editor. So you can click on this build button. So they will download something from the internet. So you have to wait. See, it's downloading something from the internet. So once it is downloaded fully, so it should download this web. So, see, what happened? There are many Java files added, right? So that is why if you use older version of NetBeans, you don't have this POM files. You have to manually add them together. So then you have to manually add this Java. But we don't need to worry about it, right? There. We just added the dependency, copy pasted, automatically it's downloaded. So we have to wait until 5 minutes. We won't wait until this all the dependencies has been completely downloaded. So any questions? I will show the template for the final paper after the next week. So they will do revision, right? Don't worry about the final paper yet. So wait until it downloads fully. Now you can see two dependencies now, right? One is Java dependencies, that is for Java version. Other one is for the test dependencies where we added our API. Now what happened? Build success, right? But there's a one thing that I missed here. We need to have plugin also. Let me open that as well. So I need to download a plugin because without a plugin you will not see the correct output. Let me show you that plugin. Okay, I will wait. Let me open that file for you. Should be somewhere. There's a plugin file. I will upload this one for you. You can use it. Let me show that. So there's a plugin file. I will help you to get it. But at the moment, you can just search org Maven Surefire plugin. Right? So search it in the Google Maven Surefire plugin. You can get from the Maven repository. So this is the plugin. 3.0. I'll use this same older version. That's fine because it's didn't change, right? Yeah. So we need to have this build section. I'll add it to this end of the dependencies. That's something called build. So just get this part pasted to your PC and just build it again. So this plugin also needed in order to write unit test. Without that, you will not see a correct output. You get some kind of exception. So what we need to have in order to test our frameworks, you need to have source code that is already there. Testing frameworks, now we download. How we go to the Maven repository, get the dependencies, added there, Sure plugin, added there. One thing is missing now. What is that? Testing method. Now let's write it until let's see until it downloads. Yeah, it's finished, right? Now it's download finished. All the plugins are needed. Now we have completed. We don't need this one. We can close it. So if you want to see the dependency graph, click on this graph section, and you can click show graph. So you will be able to see. Now this is my group project. LKS Data Academy version 1.0 unit testing project. So once you build this project, you can see what are the dependent libraries that is associated with. So you can see the Jupyter plugin is there, JUnit platform, OpenSSL, OpenTest. So these are the plugins that is directly connected to your dependence. So this can be used like this kind of graph is helpful if you want to like fine tune your source code, right? Like some companies like we call it as static code analysis. When you go to the third year, you will learn this. We are going to like optimize your source to improve your performance. For that, you have to check your dependencies, like how many dependencies are. So the more dependencies you have, that's going to be a problem to your project. So you can check whether how many dependencies coming from to your project. Like in my case, 1, 2, 3, 4 dependencies are now there. So that is libraries, right? These are libraries that is associated with this. So we have JUnit library and that. Now, in order to write a unit testing, we want to have something called test package. So in order to do that, so this is how you add test package to your project. Right click on your source code and click new. And you can't see anything here. Just click other. So when you click other, you should be able to see unit test. Right? So select JUnit test and click next. And look at the left hand side while you click next. What happened? What has added to the left hand side? Test package. So now I don't want to use this wizard. I just don't need to have it. So I just cancel it because I just wanted to have this test package added. So what did I do? Right click on the unit test, new, the project, like source package. You can say other. So you should be able to find unit testing. Select JUnit test, click next. Then you should be able to see the test package added. You just don't click finish, cancel it because we just need to generate this test package. We are going to start from the beginning, right? So we are going to start from the beginning. You need dependency. Is that clear? So now the last thing we need to have is writing our methods to test that function. So let's write it. Now we have a source code. We have the packages dependencies. All the dependencies, that means the framework is now there. Now we need to write a test package. I'm going to write a new package called test. Let's say rectangle test. Shape test. I want to shape this test, right? And we can write a new Java class. I'm going to say, so make sure it is a meaningful name. So if I want to check the rectangle unit test, I'm going to say rectangle unit test. So then the person who see the code, they can see that we are testing something related to the rectangle. So we have created a unit test for that. We don't need this code because these are necessary. Now, what is the first thing we need to have? Last thing, array list, right? We have imported something. Java.util.array list. So in order to use for the so if you want to use this for the JUnit also, we have to import something. So in the exam, you will get some marks if you add import statement. So this is the import statement you need to have. Import org. So you should be able to see the JUnit, Jupyter API Now this is how you import JUnit in JUnit version number 5. But if you use old edition of JUnit, I will use the both techniques. You have to use ORG JUnit to test it. But if you use JUnit 5, the latest edition, you have to use ORG JUnit Jupyter API. Because they have now embedded using a Jupyter engine compared to the direct JUnit framework. So that is why they have to use Jupyter API engine. So it's like the testing framework. So that is more advanced compared to the early version. So this is what we need to do. Yeah. So what I will do is you need to add this plugin here, right? Like, let me copy this into a notepad and you can paste this into your library. I'm going to copy this build section. Now, after the properties, remember, after the properties section, before the project section start, you have to copy this repositories. So let me put this into the Moodle as a file. So put this as a notepad. So this is. I'm going to save this in my desktop. Dependency. So you can get it from the Moodle. Go to the. You can get this. So click on it, copy this entire section. You have to paste it to here. Build to properties. After the properties section, paste that logic. Before end of the project. Right. So now we have our framework. We have our import statement as well. Right. So now we have to use these annotations. So like at test as before, like something you have learned something like at override annotation. Like these are some annotation, like a symbol to represent some method. Like there are some functions that you can test it, like equal, false, not null, not same, those things. But first of all, I want you to learn something like, we'll come to these methods later. Something called order of execution. For this template, you won't remember it because this is the order that we're going to execute in our unit testing lifecycle. So there's something called before class method. That is the first method we need to write. So that means in my rectangle unit test, after the import statement, we have to write a method called any method you can give, any name you can write, but that should have an annotation called at before class. So that is in JUnit version 4. So if you use JUnit version 4, you have to use at before class. But if you have JUnit version 5, there's an alternative for that. That means there's a replacement. So if you want to use the first part, you have to use before class. Then if you use the JUnit 5, you have to use before 4. That's the difference. Before class and before. And the next method is what? Before method. So before class is the first class you have to implement. Then before method, test method, after class. Now here in JUnit 5, this before all is actually before class in JUnit 4, and before method in JUnit 4 is actually before each, and after is represented after each, after class is represented with after. So what is the first class that we should implement in JUnit 5? Before class is what we have. So what is the class name we have to use in JUnit 5? Before was, right? So let's write it. So this is the initialization code. Now, before you do anything, we have to create an object from that rectangle class, right? Initialize. So initialization code is set by this logic, right? So if you want to test whether your function is insert some values to the database, we can write the database initialization query in this section. So initialize code, starting code. So I'm going to say add before what? All. Before everything, we are going to write this method. So remember, if you see now this is what you need to remember as a practice. If you see in JUnit 5 all statement and in JUnit 4 class statement, so these methods are static. Other methods are not static. So that means this is not a static method. Sorry, this is a static method because it has all statement. So this is a static method. But this is non-static method because it doesn't have all statement or class statement. So that is non-static. But this is also non-static. So what should we write now? Is it a static method or a non-static method we need to write? Now our syntax is before all. So what should we write? If you see a all statement at the end or a class statement in JUnit 5, what is the method? It should be a static method. Now I'm going to write the method any name you like, but make sure that method is static and make sure it is public. Otherwise, you will not be able to run that unit test. I'm going to say make sure it is public. So usually the method is void. You are not returning anything. But make sure it's static. I can say create rectangle. This name is you can use any name you like. But make sure it is meaningful in the case. So I'm going to create a rectangle. So how to create a rectangle? Now it is in the code package. We have to import it because we are in the two different package. I'm going to say import what? Rectangle. So you have to import that statement. So let me zoom it out. Really too small for you. Yeah, so let me zoom the font for you. It's under the font, right? Font section. Now, can you all see the font clearly? So wait until the project start because the project was shut down. So we have created a rectangle. And we have to import this code.rectangle class. Let's look at the code. Let's see. So what we have done is we imported this code class because it's in a different package, but we are in a different package. See? We are importing. So once we import it, can I create object? Yes, we can create rectangle, right? So how to create rectangle? Rectangle R1 equal new rectangle. Now since we have constructor setting values, we need to pass width and height. Let's say some hard coded values. 23 multiplied by 2. Now there's a problem. So once you create this rectangle, can I use it in another method? No, right? Because it is within the curly bracket, right? It's only within the curly bracket. Now, how do you make that variable accessible for all the class? That should be create the class like object. Now, if I create it in the main method, that create rectangle method, the problem is it's only valid that method. So where should we create that object if you want access in all the methods? Like in C++, we make it global, right? Like here also we can make it, but here, right? Variable created here, but assign it here. Right? So we don't need to create another rectangle, same rectangle. Now we have an error. Why? Can you guess that error? The typical error. This is static, right? So can you make it non-static? So if you make variable static, the calling method should be also static, right? So that means you have to put the keyword static in front of the variable in order to avoid that. So you can see the error is there. That clear? Now we have created a rectangle of 23 by 2. That rectangle name is R1, but that is accessible entire class because it is common. But if you create it here, it's only accessible within the create rectangle method. That is not what we want, right? Now we have created the before all method. One step is completed, but the unit testing is not completed. What is the next step? Look at the lecture slide. What is the next method? Now before class is replaced with JUnit 4 file. It is before all. What is the next method? Before. So in before statement, what is the alternative in JUnit 5? Before it. So that means, is it a static method or non-static method? Non-static, right? There's no all statement. So that means we can just simply write at before each, right? So we can write before each. So next method is I'm going to set this method non-static. So public void no static keyword. I can say let's say assign any name, right? You can give any name, but I'm going to make it a meaningful name. So this before each statement is executed, if you want to assign some values, now we create the object, we want to assign the values. Let's try to assign the values. So I'm going to put this answer double because I'm going to check the answer double. Okay. Let me this instead of double, let's make it integer. This it says. So I'll make it in integer. So let's make it integer answer. Now I'm going to assign the values of for the answer is equal to R1 dot. What is the method we have created? Calculated. Now if you have written this method correctly, what should be the area I should get? 23 multiplied by 2, 46. But we have error, right? We had a bug here. There's a bug, right? We multiplied again 2, right? That's error, but we don't know that. But we test whether that expected answer is what we are getting. Now we have all the before methods. Before all, we just create object, then get the values and store it in the answer variable. Now we can test whether the answer is actually 46. So what is the next method? Third method, at test. So what is the alternative in that? It doesn't say same. So alternative name is same for JUnit 5 and 4. It is at test. So it's not static method, right? So public void, let's say test area. Now what we need to test? Whether the answer is equal to 46. So that is why I have showed you in the lecture slide. There are some predefined methods that you can use. Assert equal, assert false, not null, not same. So these are the things that we can use. Now in this scenario, what is the most appropriate method to use? Now I'm going to check whether the answer is 46. So which one is good for here. Like this as a boolean, sorry, as a true, false, not null. Now what we are going to test? Assert equals, right? Very good. So we are going to check with this assert equals method. We are going to get expected value and the actual value. So what I'm going to do is very simple logic. I'm going to say assertion dot. So this is a method dot. I'm going to say assert equals. So the expected value is actually my answer. I might mix it. But actual value I'm going to get is what? 46. Right? I'm going to check whether the answer is 46. Well, now you have a problem. Why don't you write if condition? Same. But that is actually not a good way to test a logic, because if condition makes your code very complicated. But if you use predefined methods in the unit testing frameworks, they will not complicate the code. Because sometimes if condition fails, but this cannot fail because it only returns true or false. Like in this case, this only returns equals or not. But if condition based on the data type, the output might be different. So we don't use if condition loops, switch cases, those kind of conditional statements to test the function. We use assertions methods in unit test. Okay? Now we have written the unit test. Now after that, what are the other two methods? Now we need to clean the code. We have done the testing. We need to clean up the code and delete everything that we have done. Now if you want to insert the data, we want to check whether the data has been inserted. So after you insert the data, we need to clean the data. That means you delete the data we inserted from the database and clean it up. So what is the next method we need to use? After, right? So after that, we need to clean the data. So what is the after alternative in the JDit 5? After each, right? It's an unstatic method. I'm going to say after each. At after. So it's non-static. So public void. Say clean answer. We are going to clean the answer. Now currently we have answer in my code. We want to clean it up. So how do you clean it up? Set to C. The last method is what? After class. The final method is after class. So after class means what? What is after class? Afterward. So is it a static or non-static? This one is static, right? It has a all keyword in front of it. So that means we should make this method public static void, let's say delete rectangle. So if you want to delete an object, so the Java virtual machine will be able to do it easily if you set the variable of, now we created using a new keyword. This is how you create it. But if you want to delete it, you have to set that value to null. Now when you set to null, the reference will be deleted. Like they remove the reference that we have it, and the Java virtual machine will automatically remove that object from the heap area. So that's why Java garbage collection is there. So after some time, they will automatically delete the object where we have. So now we have all the methods we need to, if you want to write a complete unit test. Right? Very 5 steps. Now in exam also, the question might be different, different testing scenario, but the logic is same. Now how to run it? Can you run this code now? Yes. So how to run it? Now this time we just right click on the unit test. Earlier we run it. Now can I run it? No. We need to test it. So you can say right click and click test file. So hopefully if you have done the things correctly, it should build the project and download something from the internet for the first time. So it's actually these packages are downloading many things from the internet, right? So make sure you have a data package ready if you use this JVM test. Yeah, test. Now they run the test, but the test has been failed. This unit test failed, right? So why the unit test failed? So what is the reason that unit test failed? That means our logic is incorrect, right? So the reason is there. So what is there? We expect 46. What we get? 92, right? See? So why 92? Because we made an error in our rectangle calculate function. Now, when the developers, like the QA people, run this code, and if you see an error, they don't check whether where the error is. We just report to the software development team that there's a bug, fix it. So that is how you divide the task. Now, usually you are not doing everything, right? You are not testing and you are not writing the code. That can be done. So you have to do testing by the QA persons. So that is how you differentiate. So the whiteboard, I didn't write anything in the whiteboard, right? I just used the screen. So now how to fix that error? Now the software development team, okay, they know that there's an error in my logic because the unit test failed. Okay, I saw it. Okay. This width is actually multiplied by 2. That's incorrect, right? I fixed the bug. So there's no bug now. We need to hide. Once you fix the bug and run the unit test, you can right click and test the file again. So you can right click, test the file again, Control F6. So now this time they don't download from the internet because so you already downloaded. What happened? Test is fast. See? It's very simple lecture. So this is what we are going to do it in the today's lab. Remember these steps, right? So you create the rectangle feeding object. Make sure this is static and the object you are storing should be static. Then you, before each method, you set the values to the answers, assign it. Now that is why, right? We don't write everything in a one file. We have to write methods, right? Then testing method you can check as that equals. Now the OD is incorrect. The usually the OD is other way around, right? 46 and the answer. That is why the answer and the yeah, like this. This is the order. We check the expected values and the actual value. We expect 46, but what we get is this one. So still the unit is passed. With same. Pass. So likewise, you can write tens of millions of unit tests like this. Now this is a simple example, but if you want to write a database inserting queries, you can also do that. You have seen some Facebook comments, right? Like the government is trying to give some project to China, but in Sri Lanka, what we are handling is millions of data, right? Software companies, if you try to work in software companies in Sri Lanka, you can see that those projects are not easy projects, right? They are doing projects that have transaction millions and billions per second. So you can see the database, one database file is about 200 gigabytes if you want to back up the database. So in that case, so we can see how much power we have, but you need to learn the basics. So when you go to the second year, you will learn about the website, like the web development and Android development and those web service layers, but this is just a start. So how to develop a unit testing for everything. Is that clear? Up to now? So the next one is now you can try this example at home, like this exercise number 1. So these are exam answers. Now remember, if you want to write a unit test, be very careful. Do not write if conditions. Right? So make sure you don't write if conditions. That's bad. Switch case, that's bad, because switch case can be fair, right? But if you use predefined method like assertion dot assert equals assert not null, that is actually good for practice. Then you should use appropriate method name, right? So see how you read meaningful names, creating the rectangle, clearing the values, delete the values, and you don't use loops. It's bad. Loop is a bad for a unit testing program. And make sure you put assertion messages informative, and you should be able to use separation per type. So that means I have tested this for the integer data type. So if it is double, you can write another test like that. So the advantage is, you can see it's very fast, right? Compared to that. Now, if you try to test it manually, you have to enter the data separately. But this one, you can just write it and run it quickly. It will be able to demonstrate the output. Testing is fast. So that is advantage, one of the main advantage. The second is test isolation. So you can see the test is completely isolated from your original source code. Look at it. Now the QA persons are only working in the test package. The source code is actually independent. You can see if I highlight it in the screen. This is actually what? For QA. So they only work for the QA person. The developers won't touch usually. So this part you can do for the developers. So test is completely isolated. Now the rectangle unit test does not depending on the rectangle class. They don't have a connection. They are separate. So that's the advantage. Fast, and that is actually independent. So the next case is what? So you can say this environment is completely isolated. We can save objects. Okay, there's a problem. This should be like, I think that's it. So these are the advantage. So you can isolate your environment, you can isolate the test, and the advantage is one test is not depending on the other. So you can write another test that is totally independent. You can right click and run it. So they don't work on the other case. So and the other thing is, this unit testing gives you a safety when the programmers refactor the functionality. Now what we have done in the code, in the calculator area, we just change the logic. Now we can ensure that whether it is correctly written or not by running the unit test. It's a safety mechanism. We can check whether our unit testing is working and the software developer is correct. It's like a guarantee. So then we can use unit test as for documentation purpose, because we know that what are the inputs, what are the output values, and what will be the expected values. I think you are writing test cases in OOAD, right? Have you written that? Testing, right? Test cases. You have done that. So same like here. Now these subjects are interconnected, right? So you can see that we have now today how to write a unit test And this will helpful to make development process more flexible and easy to use. But make sure you avoid this disadvantage. Don't write unnecessary unit test that can lead to high maintenance cost to your overall project. Because now, if you write more than enough unit testing, the disadvantage is now you have to maintain the source code and the test packages separately. Earlier, you had only one, only the source code. So therefore, write unit testing only for major components. Don't try to test each small unit. So usually this has been decided by usually the software architect. So the architect will be able to see that. So they decide whether how many unit tests we do, right? So you can see how we can proceed in that section. Right. Apart from that, now similar products that you want to see, if you want to search on Google, for C, you can use C unit. C++, that's a unit. PHP, Python. These are the unit testing frameworks that you can use it for your project. Now same behavior is there, right? What is the behavior? Before class, before all, tests there. Steps are there. Even all the steps in this product. So these are some references I just took it. You can just go watch this video and see what are the additional factors. So a small lecture, right? Because we are coming to the last week of the lecture. Next week we are going to learn about the exception handling. That is the last lecture. So today we have learned how to write a unit test. So how to test the framework. So in the lab environment, we are going to test some functions that we have written in the code. So we will meet you at 10:45 in the lab number 1. So the online students also please join it. Now the online students, you can try to get the dependencies and try to run the unit test because it will take some time to download it. So make sure you copy this and paste it to the environment. So in the lab boards, we are going to try to do it. Right. So after the next week, we do a revision separately for the past paper. So I'll give you a past paper and let's try to write the answer. So those who scored like less than 10, like 13 to less than 10, make sure you register for the supplementary exam. That will be helpful for you to score the marks in the final easily. Then start working on the group project, right? So I will be getting your final project evaluation after the final exam. So after the final exam only I will be evaluating. So make sure you are already started the things. So then see you on the next class today. Okay, so we have to use generic syntaxes in the final exam. Okay, in the final exam, you can use whatever the version you like to have. If you syntaxes are like at before class, at before, and those syntaxes, still I am going to give you marks. So either 4 or 5, both are correct. You can use whatever the syntaxes you like. That clear? So this is the 10 marks for your final paper. This question is 10 marks. Like if you write the unit testing here to here, out of 100 you will get 10. So make sure you do this correctly. So you will easily get, because this is a very easy question, right? Just create the object, set the values, call the whatever the methods with the actual values and the expected values, and clean the data and delete the object. So we'll see more advanced stuff in the labs. So see you at 10:45. Join to the Zoom meeting, and on-campus students join to the lab number 1. Thank you.